Hello students, today we are going to talk about the topic atomic structure. Now before going ahead with the topic, if you want to improve and excel in maths and science, then do check out the micro courses offered by Infinity Learn and don't forget to use the coupon code HQ10 for additional 10% discount. For more information, kindly check out the description of the video. Now coming back to the topic, now let us first talk about the structure of atoms and nucleus, and there are these two events that led to the clearer understanding of the atomic structure. The first event was the discovery of electrons by Sir J.J. Thomson during an experiment, and there was this another experiment which was scattering of alpha particles by Rutherford, which led us to the clearer understanding of the structure of nucleus. Let us first start with the structure of atom. An atom consists of basically three types of particle. One is electrons, which is negatively charged. Another one is protons, which is positively charged. And then there are these neutrons, which are basically neutral in nature. They are not charged particles. Protons and neutrons, they are present in something called as nucleus of the atom. And this nucleus is at the center of the atom, while these electrons they revolve around the nucleus in orbits which are called as stationary orbits, and electrons which are orbiting in the stationary orbits, they do not radiate any energy, and hence the name stationary orbits. So if I draw an atom over here, let us say this is the nucleus which has protons and neutrons, and then we have orbits in which there are these electrons which are going around. Electrons in different orbit have different amount of energy, and if a particular atom has more number of electrons, the number of orbits or the number of shells will go on increasing. Now these orbits can be numbered as orbit number 1, orbit number 2, or they are also labeled with alphabets as K, L, M and so on. So we can have orbit numbers as 1, 2, 3, 4 and so on, and we can also label them as K, L, M, N and so on. Now all these orbits, they all have their own capacity of electrons, and it is given by a simple formula of 2n square, where n stands for the number of orbit. So number of electrons for the first case will be when n equal to 1, then in that case we will have equal to 2. So in the first orbit there are maximum of 2 electrons. Then in the second orbit, if we put n equal to 2 in this particular formula, 2 ka square will be 4 into 2 will become 8. Similarly, if we put 3 in this formula in place of n, then we'll have 3 ka square is 9, 9 2 is 18. So maximum electrons in the third orbit will be 18. And that is how we can calculate for all the orbits. As already said, all the electrons in different orbits, they have different energy levels. Higher the number of orbit, higher is the energy. Talking about the size of the atom, higher the number of electrons, more is the number of orbits, and thus the size of the atom is also more. The size of atom is in the order of 10 raised to minus 10 meter, and the electrons that are moving around in this orbit, they have a charge which is 1.6 into 10 raised to minus 19 coulomb, and the masses of these electrons is 9.1 into 10 raised to minus 31 kg. And this particular mass of electron is very less compared to the mass of proton or neutron. Approximately the mass of electron is 1 by 1840 times the mass of proton. Now next let us talk about the structure of nucleus. The nucleus is at the center of the atom and it consists of protons and neutrons. This was basically verified by alpha particle scattering experiment. Now the nucleus, since it is at the center of the atom, the size of the nucleus is very less. It is of the order of 10 raised to minus 15 meter, So it is around 10 raised to minus 5 times the size of the atom. So size of the atom is 10 raised to minus 10 into 10 raised to minus 5 will give us 10 raised to minus 15. Now it consists of protons which are positively charged, and the amount of charge this proton has is similar to the charge of electron, and the charge of a single proton is 1.6 10 raised to minus 19 coulomb. Only thing is that this one is having a positive charge and electron is having a negative charge. Talking about neutrons, they are neutral and hence they have no charge. Mass of proton is 1.67 into 10 raised to minus 27 kg, and mass of neutron is also very close to the mass of proton. It is slightly higher than the mass of proton, but roughly it is also 1.67 into 10 raised to minus 7 kg. Now the nucleus which is made up of these protons and neutrons, these protons and neutrons are also called as nucleons as they are found in nucleus. And we have something called as atomic mass number, and atomic mass number is nothing but the total number of nucleons. Atomic mass number is denoted by capital letter A. Similarly, we have something called as atomic number, which is denoted by capital Z, and it is nothing but the total number of protons in an atom. Also, it can be equal to the total number of electrons in a neutral atom. So we have got two things over here: atomic number Z, which is nothing but the total number of protons or the total number of electrons in a neutral atom. Then we have atomic mass number, which is denoted by capital A, and it is the total number of nucleons, protons plus neutrons. Plus we have also seen the masses and the charges of the protons, neutrons and electrons. Next, let us talk about the atomic model. So atom is electrically neutral, and therefore the number of protons is equal to number of electrons which are revolving around the nucleus. So we have Z, which is representing the number of protons or electrons, and then we have atomic mass number, which is the number of nucleons, protons plus neutrons. Now if we have any element X, then it is denoted by the symbol XIZ. So in case I have an element carbon, so carbon is denoted by capital C. The atomic number of carbon, yani the number of protons, is 6, and atomic mass number, the number of protons as well as neutron, is 12. So this is how a element is represented with atomic mass number and atomic number. Let us quickly draw atomic models. So first we will talk about hydrogen. Hydrogen has only one proton and it does not have a neutron. The nucleus has only one proton, and in the first orbit we have one electron which is going around this in this stationary orbit around the nucleus. Let us take one more case of helium, where it has two protons and two neutrons, making the atomic mass number as 4. So helium nucleus has 2 protons, 2 neutrons. Also the helium atom has only 2 electrons, which is equal to number of protons. Similarly, we can do it for carbon. Carbon has 6 protons and 6 neutrons in the nucleus. In the first shell it will have 2 electrons, and in the second shell it will have 4 electrons, making the total count equal to 6 electrons. So I hope the atomic model is clear to everyone. We have center main nucleus with protons and neutrons, and the electrons orbit around this nucleus in stationary orbits. Now the next topic that we are going to talk about is isotopes. Now what are isotopes? So isotopes are atoms of the same element which are having the same atomic number Z, means the number of protons or the number of electrons will be same, but they have different atomic mass number. Now when I say number of protons are same but the mass number is different, which means यहाँ पे जो number of neutrons है, it is going to change for the elements. The first example that we are going to take is of hydrogen ka family of hydrogen atoms. First one is protium, which is having one proton only and there is no neutron. Then we have deuterium, which is having one proton and one neutron. And then we have tritium, which is having one proton and two neutrons. So in all these cases, if we see, the value of Z is same, but the value of A is changing, and which can be seen that it is nothing but there is this difference in the number of neutrons that all these elements are having. Similarly, we can take another example of carbon. Carbon has different isotopes C12, C13 and C14. So C12 has 6 proton and 6 neutron. C613 has 6 proton and 7 neutron, and the third isotope has 6 proton plus 8 neutron. So once again, as we can see, the number of proton is same, yani Z is same, but यहाँ पे the number of neutrons is changing, which makes A also different for all of them. But please note, the number of electrons is still same, so the chemical nature does not change and the elements are carbon only. Now let us talk about something called as isobars. Isobars are atoms of different elements which has the same mass number but different atomic number. Let us try and understand this with an example. The first example that we are going to take is sodium and magnesium. We know sodium has atomic number 11 and magnesium has atomic number 12. So the atomic number is different, Z is different in both the cases. But sodium has an isotope which is having Na23. But over here sodium also has atomic number 23 and magnesium also has atomic number 23. So over here in sodium there are 11 protons and 12 neutrons, and in the case of magnesium there are 12 protons and 11 neutrons. So neither the number of protons are same, neither the number of neutrons are same, but their addition is same, which means A ka value is same for both the cases. One more case that we can take is of carbon, which is C614 and N714. So in both the cases, as we can see, the number of protons are different and neutrons are also different, but their addition is same, which is equal to 14. So these are called as isobars. And lastly, we have something called as isotones. So isotones are the atoms of different element which are having different number of protons, but the number of neutrons are same. So you will have Z also different, A also different, but their difference A minus Z, which is nothing but N, to be equal to same. Let us try and understand this with an example. So we have sodium, which is Na1123, and then we have magnesium ka one isotope which is Na1224. Now in both the cases what we see is neither Z is matching, the atomic number is also different and atomic mass number is also different. But when we take the difference A minus Z, in this case what we get, this is the number of neutrons. So number of neutrons in the first case is also 12 and in the second case also it is 12. So the number of neutrons are same over here, and these elements which are having the same number of neutrons but different number of protons and atomic mass number, these are called as isotones. I hope the topic is clear to everyone. Thank you very much.